You got to come in. Yeah, yeah. Last time you got 47. And then we're going.
Oh wow, I didn't know that.
Okay. So you came up with that because you came up with the lift, right?
No, we tried to,
What'd you do?
so we did 5, took it out 5, we times 3, split it.
So 5 of these, and you multiply it by 3, and then you did what with it?
And let it go.
And you multiplied it by 3. And that gave you what?
60. And then we took 60 and divided by 5. We probably take 60 and divided by 15.
So the only thing I'm going to say is make sure that the calculations that you're doing, that you know why you're doing them, that you have reason for doing them. You might actually be onto something, but you're not going to know what you're onto unless you know why you're doing it.
No, that's cheating.
So adding 5 or multiplying 5 of these times 3 of these. I'm not sure I know what that is. Keep trying, because I'm not sure. I'm curious.
We know there's 8.
How many of these?
Maybe one of these could be 15 by 15. 8 cells.
So 8 stones, right?
What about that? 5 times 3. They all equal 4.
One length and one width.
Do we use our gas?
Like it.
I think putting in your guess might give you the answers that.
So we can find the width. This and this is 4.
Okay. That's true.
This is 8.
We have 2.
We don't know. Close. Really close. So this length right here. Let's just look at this little one. So they all match up perfectly, don't they? These 3 lengths kind of fit perfectly on top of the 5. So what does that tell you about these lengths and these widths?
3 widths equal to 5 lengths.
What did he say?
3 widths equals 5 lengths.
Other way around.
No, 5 lengths equals 3 widths.
So you have 2
Could be
widths?
possible.
Yeah.
You're so smart.
Sometimes. I wasn't there.
Then what? X plus y equals 8.
First, before you just do all of that work,
X plus y.
just right.
I know, we're only thinking that no one else can. This is something. You're something what? No, that's what we're doing now. We're supposed to forget the function. Put in basically. No, I know, but it's kind of like it adds up 4.5, 2.5, but I kind of just put a 50 is why I didn't know what else. Like, I mean,
5x and 3y. What did you
widths and 3 lengths.
5 widths and 3 lengths. They match up perfectly outside. They're like one nice little box right here. So what could you say about those 5 widths?
To switch to very
3 lengths? Yes, they're equal to the same length, or they are equal. Right? They're equal. So instead of adding them together and trying to work them because we don't know what that's going to be. What if we said that
So it's just telling us what we find a way.
Yeah, so it's 3x plus 5y. No, it's 5x.
Oh, I know what to do. We gotta substitute for it and for the L.
What to what?
For and for the L. I mean for the W.
What?
We gotta substitute for W because it's the width.
I know. Okay. We're going places today.
Then what do we do?
So then,
So you times
yeah,
three,
but the, yeah, but it's
you times 3. 5 divided by 5.
Do you want the decimal? We're gonna put it as decimal. 2.4.
Huh?
2.4. So that's only a length.
So yeah, put it around times 4 plus 4. And we gotta subtract 4 to both sides.
Minus 4.
Any numbers here?
You got L equals 0. So how does that work?
You tell me about this. 5. Just 3.
Where'd you get 4 from?
Yes.
Huh?
That's
Wait, what? Oh, I don't care. Huh? Okay, and look at
How'd you order that?
So how can you do your 2
You
equations?
girls scoot your desks over and you girls scoot your desks around.
Man, how long you take this?
Okay. Explain to them what you did to equate, okay? Okay, I will understand.
I thought we were gonna be this.
Well, does it matter about the
I thought my calculator brings to technologies and OT into.
We got that. And then the second one is 3L equals
amen to that.
5.
We're on to something.
See.
Keep working on it.
I would like you guys to share. I would like you guys to share with them how you. That's it.
Because we don't know which
She said she could be horrible at drawing, and if she could mean that this one should be 1 and that one should be 3, or it could be 5. She said, but don't use the 0.5, so you like round it up to a number, so 3. So that's what I feel like we can't use already in one equation. Well, this is so you can find the exact same thing. So once you find the thing that is, you just but what is
this, like going horizontally, has to do with the width. That's why I'm confused on why we're using this equation, because we're not worried about the length yet.
But you need the length. You need to know, like, okay, it's like, so you figure out, like, if you add at intersection, say that you would add these up, so say that they were 1.5, and you add them up, and they both equal the same thing, because they're the same length. So,
Oh, I see now.
get on there. Yeah.
X represented your width. So that's why you said X is 1.5 to X is width.
And then we could do this one 3. It's either or.
Yes, nice and big on the word.
And
Dude, I want this.
We proved it.
Wait, on the same side or?
I just want both equations written on the map before I give you.
Doesn't matter how big it is.
No, big enough so everybody can see it.
Wait, what do you mean?
No, I'll talk to Raymond. If he was doing one equation.
Go ahead. Yes.
7.5 has required
So I think we're kind of stuck on knowing what we think the answer is, right? So what these guys are doing at the front right now is writing 2 equations. What I want you to do is talk about how you think they came up with those equations. What do those mean? Does that make sense? Look at your picture. Very good. Okay.
camera's not.
It's the same thing. I don't know.
So we put the green, you guys already did, like, you solved for L, the green one?
You saw? Yeah.
Put the wrong one. I would just need always use it. Shut up.
What, did you put it?
Son,
You want me to go to the other one?
Yeah, because we simplified it. Right here. Right here.
How do I tell?
we don't have to. We should have. So do you want to?
No, they just didn't use X and Y. That's
Alright, you guys, we're going to, I'm going to give you like 10 seconds to finish writing what you're writing, and then we're going to look up here and talk about the problem. So finish up your last thoughts, your last conversation. I'm okay with it as long as it's explained why you did it. Alright, everybody up here, please. Can I get everybody to swivel around on their desk and face the front? So if your desk is turned, that's okay.
but I want you guys to both swivel this way so you can see the front. Okay. Alex, did you have a question that you wanted to ask the boys? Speak up so I can hear you.
Would you like to explain something like that? What? Both equations? Oh, we did math.
Do one of you guys want to explain why you came up with those equations?
Well, we got 5L equals 3W because when we look at our thing, we can see that the 4 lengths going up and down equals 3 widths. It's hard to explain.
Does everybody see that on their page?
Yes. No, the 5 lengths equal 3 widths. Look, this is the width, this side is the width, right? Okay, so there's 3 widths equal 5 lengths. So then get.
Yeah, you get there one.
Raymond. You can point using this. Tell them what you meant.
The 3 widths equals the 5 lengths.
Does everybody see how we came up with 5L equals 3W? Did you guys use L's and W's or did you come up with other variables?
X and Y.
X and Y? I'm okay with either. That's fine. If you're going to use X's and Y's, then you might want to write on your page, X represents the width. Y represents the length. Okay, what about the second equation, boys?
Because it says that. Oh, you want to finish?
On the side it says it equals 4 feet, so a length plus a width equals 4 feet. So we just made the equation L plus W equals 4. And then we simplified it by subtracting L both sides. And we got negative 1 L plus 4 equals.
Good. Why did you do that step? Why did you do that? Why did you...
Because we had to get one of the variables on one side.
Why? So that you could do what with it?
So we could graph it. And then once we graph it, we use the intersection point to find the length.
Did everybody hear that? Yeah. Say that one more time nice and loud.
Once we graphed it, we use the length and the width. So we use the intersection point to find the length and the width.
Good. You graphed the one line, you graphed the other one, and then you found this intersection point. What was the intersection?
2.5. 1.5.
So what does that mean in context to this problem?
Oh, the length is 2.5.
Go ahead. Say that louder.
The length is 2.5 feet and the width is 2.5.
Awesome. Does anybody have any questions for the boys, for me? Any questions? So, yes, Nancy? How did you do it? You did it all in your head? So, I think some people were trying to just guess the answer. That's great. That's a great start to the problem, right? But I think it's always a good idea to come back to what do we really know? How can we set up these equations and how can we solve them? What does that tell us?